We have to. We have to graduate.
Just
Graduate.
coming back to us.
Okay.
What is it?
I'm like, this is happening.
Just over and over again.
Yeah, I feel like I'm bored.
Yeah. And then finally, after
Just
a
kidding.
long time, that body eventually comes up and it's just like, okay, so you don't really need any of this, you can just replace it.
I'm just scared for the organic class because it's like straightforward.
How far are you in hiding the identities?
I think it's back there.
Did you do
No, we did not.
Oh,
What are we doing?
we still got
I didn't
last time.
Oh. I know.
Huh?
Did you guys might cheat? I know.
Okay, and we need to do it on the first.
We could just do the switcheroo again.
Well, I think that's what we are.
Ah, if I want to have it really secret, I should keep it with me. Otherwise, you can read the symbols. So I'm not very good at hiding.
We passed it to the class.
Yeah.
Yeah, right? I mean, it doesn't.
Well, maybe in next generations or class next year, I will be better.
Shuffle.
How to say, yeah. Learning about arranging security.
Yeah,
Nowadays,
card shufflers.
Just a prototypical
One for
protocol.
like paper.
Yeah.
Symbol in there.
Okay, it's not.
Oh, wait a minute, yeah, we're gonna be short.
Look at these notebooks like this.
Oh, wait, never mind, we got this whole side.
I don't think I had that. Jeez.
You are rough.
That was
It's not fun enough very well.
Beth was just like one night
But it only has to
working on the
last-
PChem and was like, no.
It only has to last another.
Yeah, that's this next week.
Those can't be cheap. Sigma was too boring.
Founded usually is not cheap.
Oh, God, can you get this upside down?
That doesn't surprise me. It's like a sketchbook.
I can remind you your symbols if you are out of creativity. I will not. Ah. Here's your symbol.
Like helium.
Oh, no, you can.
Oh, okay.
Just,
Oh, no, I wasn't.
Whatever.
I was going to last.
So much symbol.
Done?
Put methanol.
I've never do these upside
Yeah.
down. There we go.
I mean, I could do caffeine. They are both on my coffee table. Like,
Yeah,
literally.
caffeine's a pretty large molecule.
Excellent, thank you.
I mean, it's not.
So let's pass around maybe. No, more. Last time we did neighbor, next neighbor.
So.
Otherwise, it will be
over.
boring to have.
you guys just
keep
arrived.
it.
I get my own back.
Huh?
Yeah, so then if we do it twice.
Super.
They broke the
I don't know.
system.
Yep.
Let's.
100%.
Oh, sure.
There we go.
Let's program.
Yes, done.
Sorry.
Go. Yep, just one. Perfect.
Okay, we're good.
You get from first table.
Oh, yep, we can switch more.
Switch more.
That one is actually
Yeah,
semi-random.
we
Do
don't.
you switch or you switch?
Oh, what is?
Yeah,
Switch
just
between
switch.
tables.
Who doesn't have one?
Oh,
Did you
well,
got-
it's
Here.
you got
Did you switch
apparently.
between-
I guess I'm grabbing where
Yeah,
that
they
is
can
now.
That was the best. I don't know
There
what else to do.
Now I'm
Fun.
now I'm officially
Then someone
lost.
else is missing
Who
one.
doesn't have
Oh,
one?
here's one.
Was that awesome though? Okay.
Nice, alright.
Everyone is ready?
Yep.
Supposedly. For a second, it looks like you got yours back.
I know, I thought so. Like, really.
Oh, God, it's so thick. Should be in it.
So let's distribute grades between assignments. Out of 100, 10 to the easiest problems, which are 1, 2, and I think one, 2, and 4.
1, 2, and 4.
Yes. So
Graduate edition.
They're not.
I'll just put
Oh, what?
number 3 is the hardest, so it is like 40 points. Number 4 is easy, so it's 10 points, and number 5 is 30 points. So you can enjoy reading it on your own, but I will go through. So if you have some doubts, I will just cover whatever it is. So number 1 was to practice commutation, right? And it is just nothing by applying derivative of a product. So in first case, derivative of x squared is 2x, so you get minus x, and you see that swapping order of operator and derivative, like two functions, derivative and function is not equal 0. And when you do for arbitrary function and apply the derivative of product to the second term, you get two terms, right? So the last term here and first term overall cancel, and then you get minus 5. So it is just illustration of general principle of commutation, and specifically this one is very applicable to commutation of position and momentum operators which give a constant. So if you remove the auxiliary function, you get that the commutator of operators is not 0. How to grade? Just be liberal. Do maximal. If you see answers, give full points. If you see little shortcomings, just withdraw a little bit. But be nice. Perform to others in the same way as you want to others to perform towards you. So number 2. It is trivial. So as an input, you use Hamiltonian and initial condition for the wave function at time 0. As an output, you get wave function at any time, and then you use your third way to predict the future by plugging in eigen functions, eigen energies, and expansion coefficient, which is obtained by convolution of the eigenfunction and initial condition. And functions and energies are coming from time independent Schrödinger equation. So number 3. In general, it is easy, but it is a lot of steps. And if one fails in the intermediate step, then the answer will be wrong. Before we go into details, if you are busy, do not bother looking at the screen. But if you are relaxing, so the question is as follows: if we do have wave function as a Gaussian wave packet centered around point x0, what will be expectation value of the position operator? So you just see where the center of distribution, so you can write x0. So if you see someone is doing this, if you see the right answer, you can immediately give like at least half of the points, right? Just for a clear mind and understanding what we are doing. Now, the boring stuff, how to get it mathematically. First, our wave function is not normalized, which means this n coefficient is not known. Where do we get it? We need to match the conditions that probability of all possible events, probability cannot be more than 100%, right? So if the mean of the wave function squared is probability distribution, that adding it over all area of definition, it should be 1, 100%. So you have wave function squared and make it equal to 1. And since in the wave function you have unknown coefficient n, you need to pursue this stuff, this normalization condition, as an equation to find n. So it is maybe 30% of a problem. So if the n has been found as a square root of 2 over pi, you can give whatever, like, plus 8 points. So, and there you need to square your wave function, and remember that integration of Gaussian function will be square root of pi. And then you observe that your unknown normalization constant times square root of pi and divide by 2 appears from playing, redefining the variables, equals 1, and then you just solve for n, and you get that it is square root of 2 over pi. So I do not see much interest in this, which means that you are done with this step. Now, after you do know the normalization, and we are pursuing the bridge that connects wave functions to real world. You have wave function conjugated, wave function without conjugation, and operator. There are no complex numbers, so the conjugation doesn't change anything. So therefore, we just put factor 2 here, because if you multiply two exponentials, their powers add together. This one comes from square of normalization constant. So we have x, and then we start playing our favorite game. Multiplying and dividing, adding and subtracting. Right? So, what is the logic? How do we think in the right way? The only thing that we, only mathematical relation that we know by now is, well, maybe not the only one, but one of the very few things that we know for sure, we confirmed in class, that integral of Gaussian function will be square root of pi. So we try to identify it anywhere where we can see it. And if you want to see integration of e to the minus z squared, we see that this combination of 2x minus x naught square is not an ideal, x is not an ideal variable. We want to bring this term into a form of just e to the minus z squared. Then this variable x can be subtracted, minus x naught, and then to keep identity we do plus x naught. So add and subtract. And under the sign of differentiation we can add or remove anything. Then, what is the next step in logic? So we have a good variable that has good chance to be integrated. And then we have this problem-making term, plus x0. Why don't we split this integral into two integrals? One that contains x minus x naught, and another that contains x naught only. Right? And then we will pursue this integral number 1 and integral number 2 separate. By the maybe you are bored and you want to see the answer. The first one will be 0, second one will be x naught. And if you are curious about details, I can swim through them. So first integral. I'm not happy with this factor 2, so I may redefine the variable by putting this factor 2 in multiplying x minus x naught. And then we can, I don't know the right word, insert, submerge, sink, place function under a sign of differential. So we had like x dx can be always replaced by dx squared over 2, right? So you can take not all integral, but only the fraction. So we have derivative of this x squared function. And then it's not the end of the story. We identify that we have differential of y squared, and in the power we have minus y squared. So why don't we replace this y squared as z, new variable? And then it becomes super simple. It is e to the integral of e to the power minus z dz. So it is something that we can take for sure. And if we carefully process it, one will see that in these limits it is 0. Give me signs if I need to speak more on this. No. A little step aside from these boring derivations. You may ask yourself, why do you spend this much time on this boring task if you are done with particle in a free space? Are we going to see Gaussian functions anymore? If you are done with them, why should we bother playing with them?
We're not done with them.
Gaussian functions will return on you. They're unique. Well, you will be either angry on me or laughing on me when I will tell that they're easy. But they're much easier than many other things that are typically needed for quantum theory. So we will stick to them and try to deal with them as much as possible. So first integral is 0. Second integral, x naught is a constant. We put it outside of the integration. And then we do have e to the power some variable squared with derivative over this variable. So it will be, we can replace this one as same as before, y squared and this dy. And we will multiply and divide in such a way that we do not violate the identity. So the factor that we need to bring in this square root of 2, this square root of 2 divided by pi comes from normalization, and then we know that integration of Gaussian function will be square root of pi. And then we have x naught, 2 over pi, pi over 2, which cancels, and then we get the answer x naught. So it coincides. I'm going to jump back 3 slides. 1, 2, 3, 4. With our intuitive expectation that if you have symmetric Gaussian distribution around position, then by performing the protocol to find expectation value, we will find exactly this center distribution. So it's not a big surprise. It's natural. Right?
Mm-hmm. That's how I knew I screwed up right away.
Huh?
That's how I knew I screwed up when I did it the first time.
I screwed it up 3 times while preparing the answer.
Same here.
Okay, so 40 points if everything is correct, and withdraw just by 1, 2, 3, 4, 5 if there are some
40 or 30?
40. This one is the heaviest problem in the whole book. Number 4, 10 points. You see some combination with h bar square, and then it grows linearly as a function of time, quadratically. But if we inverse time, if we go backwards, then it will decrease, right? Well, right now, we do not have any marker, any rule that gives us direction of time. We can go backwards or forwards or backwards, nothing will change. Same as in Newtonian mechanics. If you inverse time, all equations are still correct. But give full points even if there is no saying about going using worse times. So, and number 5, which is worth of 30 points, is very related to what we do in class, what we should do in class today or on Wednesday. So we are solving boundary condition. So if you remember a little bit what we were chatting last Wednesday before your hour of glory on Friday, we agreed that, at least what I remember, 8 electron volts equals infinity. Therefore, for many objects we do have infinite walls, and this infinite walls mathematically can be translated into condition that boundary conditions, that wave function at x equal 0 and at x equals, at left and right edges of the box it is equal 0. Now, if we suppose that the trial function is just a summation of sine and cosine with unknown proportions and with unknown pace, rate, factor in front of argument, we can see whether such trial function does match the boundary conditions. And we do not need to do anything except plugging in values of argument at boundaries. So if we plug left boundary x equals 0, then sine becomes 0, so we don't care about it right now. Cosine becomes 1, so we get that function is equal b at the left boundary. But through our requirement, because of the infinite walls, it must be 0. We require it from function. We require it to be 0, but mathematically trial function is equal to coefficient b. So from that comparison, we see that it can be achieved only if you set b coefficient equal to 0. So by now, we already narrowed down the class of functions to phi equals a times sine alpha x. That's it. So we do not have b coefficient and we do not have cosine. It's already simple. Now, at least 10 points if this step is achieved, or even 15 to be generous and liberal. Now we plug in the right edge. X equals no. So at right edge, we set up an equation that coefficient times sine of the argument where number L is replacing the variable x is equal 0. Let's forget about a coefficient. We already know that it will be normalization and it can be found, same as we did in problem number 3. So just sine of rate alpha times number L, which is size of the box, equals 0. So when sine function equals to 0, let's draw it. Two pi, 3 pi, 4 pi. So when there are integer numbers of pi, so this argument equals integer number of integer amount of pi numbers, right? And then we solve for alpha, dividing both left and right by L. So the rate alpha is pi times n divided by size of the box, and then we plug it into the answer. And I was just lazy to solve for normalization. It should be something like square root of over something like this. Okay, so please give me signs if you are done with grading.
How many points is number 5 worth?
Huh?
How many points is number 5 worth?
30 total?
What would you say I should be here? What would you say I should be here?
Well, be liberal. Suppose that you did the same and you want to have a reasonable grade. At least put something for an attempt. Yes?
On the extra credit.
At least 40. If at least 40, because I'm not showing it. We will cover the problem that is considered as extra credit again and again. This is it is too early to speak in details about it, but later we will go through this problem several times. So about psychology of undergraduate students, please do not consider each other as competitors, or do not put too much. So if you get 100 points, it is already completed by 100%. This extra credit is given only to add over the 100%. So even if you haven't done it, do not worry about grades. Do not be jealous to your partners if they did it and you didn't. So you are doing fine even if you didn't start the 6th problem. Please give me signs if you need more time for grading, and please give me signs if you want some comments on any of the problems.
So,
So, is the 40 points just to go to 100?
Plus, well,
Above?
yes. Maximal grade is 140% if all 6 problems are made.
So I thought, okay.
Yeah. It is agrees with what I do. So no one requests more time. You authorize me to go around and collect, right?
I totally forgot about that from last night. I was working on 2 lab reports last night.
Yeah.
I was working on multiple lab reports. I completely just lapsed the fact.
I think I will just give brief comments of our plans and then we'll depart in peace. You worked hard in preparing homeworks and in grading, so we will play with model of particle in the box for substantial amount of time. So the problem number 5 is a key to time independent Schrödinger equation, which will serve as a basis to look on time dependent phenomena. So what we skip now is to look on box with boundary conditions and discrete solution, but in some sense our homework covered it. I don't know about you, but I feel too much concentration and too much exhaustion on doing this analytical. So next homework should be based on MATLAB, so that you do not dry your young brains. And I will announce it on Wednesday, and on Wednesday night we will do it together if you're interested. Yes?
Is that lab like always open with it on there? Cause
Yes,
I got it
yeah.
approved to be on my computer, but pretty sure it would like literally turn my computer into a brick if I like download it.
Oh, really?
I
How
think
old is your
that if I
computer?
downloaded MATLAB onto my computer, I'm pretty sure it would not work anymore because it's already like full and old.
Well,
That lab is open.
Okay.
Yeah.
this lab
They're
is
on the-
open, and
They're on the library computers too.
Oh,
It should be on pretty much most systems.
Yes.
well, it should be, but some right now there are regulations that if the software is not used regularly, the IT removes it from classes.
So
But there is a
QED then.
material modeling studio. I think it is led
Oh.
203,
Is that always on lab?
which yes.
Oh.
It belongs to chemistry. IT doesn't protrude their
Yeah.
bloody hands to it. Yeah, on the record. I need to- And MATLAB is installed there. So
Okay.
you can, come and play. But it is
I'll show
recommended
it to you
that,
after
that
this.
you try it on your laptops.
It's not in his office.
What else? Yes?
Do you have any kind of idea when we're looking at the next test for like a time frame,
What do you mean next test?
like a test
Test?
in
The
general?
syllabus doesn't have one.
I know.
You want some tests?
No,
No.
I'm just curious about a time frame.
There's none. I think
No, there's.
Never
Well,
mind.
if you guys
Never
will
mind.
insist, we
No,
can
no,
set
no,
up
no.
exams.
No.
But I think homework is already big load on you and on me. Let's minimize them and make maybe accent on presenting, running some codes in the lab. Everyone is happy, everyone gets reasonable grade. So you are getting a lot of new information. You thinking about it on your background, even if involuntarily. If something shocks you, you keep thinking, and it is already a big load. I'm sure you will have something to remember about this class in year, 5 years, 10 years. So let's not overwork and make it too hard. We can later, by the end of the class, we can make democratic votes, like someone who is like, if there are more than 50% who insist on exams, I can do it. Okay, so 1, 2, 3, 4, 5, 6. So about 2 weeks for particle in the box. So we will chew it from each side, predicting future, finding observables, many things. And then in 2 weeks we will start another simple problem, just harmonic oscillator, which relates to infrared spectroscopy. Okay, enough. Let's
Thank you. You want to know anything
get some
about
relaxation and see you on Wednesday.
Yeah, got
Is it on my way to Oswald?
Yeah, actually. If you're going to the office first.
Yeah, I'm just gonna
Yeah.
do what she did.
Okay. Yeah, then we'll run into
Nobody has labs
Monday.
on Monday, so you have to be
In-
at all.
So I made a mistake on one line.
And I don't know if I was machining, I was doing my reaction.
Okay, that's like how long?
Well, the setup is pretty quick. It's 1 hour of reaction, and then cleanup is about half.